Hi everyone. Today we're going to study surface area of a combination of solids. How to find surface area of a combination of solids? We have some steps. Step 1. Try to break the problem down into smaller and regular solids. Step 2. Solve the surface areas of smaller solids respectively. Step 3. Add the corresponding areas of the smaller solids. Example 1. Rashid got a playing top that is Latu as his birthday present, which surprisingly had no color on it. He wanted to color it with his crayons. The top is shaped like a cone surmounted by a hemisphere. See this figure. The entire top is 5 cm in height and the diameter of the top is 3.5 cm. Find the area he has to color. Take pi equals 22/7. The required area here is the total surface area. That is equal to curved surface area or CSA of hemisphere plus curved surface area or CSA of the cone. Let us solve the CSA of hemisphere and CSA of cone separately. Let's begin with the CSA of hemisphere. The formula is 1/2 of the formula of the sphere, which is 4 pi r squared. We can simplify this 4 by the denominator 2. That becomes 2 pi r squared. When we substitute the values, we have now 2 times the pi, that is 22/7. And the radius of the hemisphere, that is squared. Looking at our figure here, the diameter of the hemisphere is 3.5. Half of that is the radius. So we write here 3.5/2. Then we squared. We can simplify this using our calculator. And the answer is 19.25 square centimeter. Next is the CSA of the cone. The formula is pi r times L. L here is the slant height. Let us solve the slant height first. So L equals the square root of the quantity r squared plus h squared. Our r is 3.5/2, that is squared, plus the height of the cone. Looking at our figure, the height is 5 minus 3.5/2. Then we will square. We simplify the first fraction as 3.0625 plus the difference here is 3.25. Then we will square. The sum, then we will take the square root. The total will be 3.6912. This is the L. And this value we will use in here. So the CSA of the cone, pi is 22/7. The r or radius, 3.5/2. And the L value, which is 3.6912. Final answer is 20.3 square centimeter. So these two areas we will substitute in here. 19.25 plus 20.3. Total is approximately 39.55 square centimeter. Note here that the total surface area of the top is not the sum of the total surface areas of the cone and hemisphere. Example 2. The decorative block shown is made of two solids, a cube and a hemisphere. The base of the block is a cube with edge 5 cm, and the hemisphere fixed on the top has a diameter of 4.2 centimeter. Find the total surface area of the block. We take pi equals 22 over 7. This is our figure. The total surface area required is equal to the CSA of hemisphere minus the base area of the hemisphere, then plus the CSA of the cube. The formulas are here. The CSA of the hemisphere is 2 pi r squared minus the base area is a circle. That's why in here we have pi r squared plus for the cube CSA is 6 times s squared. When we substitute the values, we have 2 times 22 over 7. And for the radius, look in our figure. The diameter is given as 4.2. So half of that is the radius. So we write here 2.1. Then we square. Minus pi is 22 over 7. R square is 2.1 square. Plus 6 times s square, and that is 5 square. The first group here is simplified into 27.72 minus the second group is 13.86 plus 150. When we simplify, the final answer is 163.86 square centimeter. Example 3. A wooden toy rocket is in the shape of a cone mounted on a cylinder, as shown. The height of the entire rocket is 26 centimeter, while the height of the conical part is 6 centimeter. The base of the conical portion has a diameter of 5 centimeter, while the base diameter of the cylindrical portion is 3 centimeter. If the conical portion is to be painted orange and the cylindrical portion yellow, find the area of the rocket painted with each of these colors. We take pi equals 3.14. This is our figure. Let's begin with the area to be painted by orange. That is equal to CSA of the cone plus base area of the cone minus base area of the cylinder. We substitute the values. We have pi r times L plus pi r squared. R here is the radius of the cone minus pi r prime, and that is squared. R prime here is the radius of the base area of the cylinder. In the first formula, we need the value of the L. Let us solve for L. And that will be L equals the square root of R squared plus H squared. Looking at our figure here, the R squared is 2.5, and that is squared, plus the H squared, that is the height, which is 6 squared. Simplifying further, we have the square root of 6.25 plus 36. We get the sum and take the square root. Final answer is 6.5. Then we can use this value and substitute it here. So finally we have 3.14, that is the pi, times r is 2.5, times the L, which is 6.5, plus the area of the circle, 3.14 times 2.5, which is squared, minus pi is 3.14, and the radius of the base area of the cylinder is 1.5, and this is squared. Simplifying each of the group, we have 51.025 plus 19.625 minus 7.065. Finally, the total is 63.585 square centimeter. We write the answer in here. Then we go to the next computation, the area to be painted yellow. And that will be the CSA for cylinder plus area of one base of the cylinder. Substituting the values, we have 2 times pi times r prime times h prime plus pi times r prime, that is squared. We have now 2 times 3.14 times the r prime is 1.5 times h prime is 20 plus pi is 3.14, r prime is 1.5, and this will be squared. When we simplify the groups, we have now 188.4 plus 7.065. And the total is 195.465 square centimeter. This is the area to be painted yellow. These are now the final answers.